And we are live, as far as I believe. Let's check it. 1 second. Okay, we are live, at least on YouTube. So hello everyone, sorry for a super small delay, but we need to configure things. Sometimes technical problems are always with us and we need to diagnose them, right? So we are super happy we are here today with us. We will be talking about memory dumps. We have Sebastian Solnica, which is super proficient expert in diagnostics topics and in .NET, and not only in .NET, but also in Windows, Linux, and in general. You love solving things, right?
Yes, thank you, Konrad. Thank you for introduction.
So today we will cover the things that you see on the slide. So we will be talking about types of memory and how you can use the memory dumps and for what. So as always, we are super happy that you are here with us today. So just say hello, say from where you are with us today, from where you want to diagnose things, from what countries. And maybe Sebastian, you could say a few words about you.
Yeah, sure. So as Konrad said, my name is Sebastian Solnica, and I have now, I think, more than 15 years of experience in software engineering. Most of the time I work with .NET, but I always like to dig deeper and analyze also the system level of maybe not the kernel, or although sometimes I was debugging some kernel things, but I would not call myself a kernel developer for sure. But I really enjoy learning about the layer between the operating system and applications. So I was quite happy when we decided with Dotnetos to make the diagnostics course. So
yeah.
We were able to.
So you created this huge brain dump of your knowledge about diagnostics in the form of this course that we would like to mention today, because we have opened the sale of this course. So if you are interested in .NET diagnostic things, please look around at the site that will be soon posted also as a link on chat, so you can just click on it and see what we are giving you there. It is all about, as you see, .NET covering various things, Windows, Linux, and if you are interested in that, just look at the agenda. It's a lot of weeks and a lot of material. Sebastian knows how much materials is presented there. Yes. Because you spent a lot of time doing this. So just look at this course if you are interested, because today we have an opportunity to listen to Sebastian, who is an author of it, as a kind of trial or evaluation of what he is able and capable to do with diagnostic stuff in general. So look at this site while listening to Sebastian. And in general, I believe, without further ado, because we want to hear you, I will just give the scene to you and start your presentation, please.
Okay, I hope so. Konrad, are we sharing already?
Yeah, we are sharing already.
So when we were thinking with Konrad what would be the right topic for the webinar, I decided that maybe the memory dumps, because the winter is coming, the evenings are longer, and there is the hot coffee and the memory dump for analysis could be a nice choice for winter evenings. Of course, I'm joking, but it's just to mention that analyzing memory dumps could be long activity, and I will talk about it in a moment. So, but just
I will just make a short sorry, before we will start your brain exploding things. If you will have any questions, do not hesitate to ask Sebastian. Probably we will gather most of the questions at the end to not interrupt your flow, but maybe I will decide to interrupt you. We'll see. In general, just do not hesitate to ask any questions.
Yeah, exactly, because the interaction is really great during webinars. I know that probably there will be some people who took the course already, which joined the webinar. So decided that I won't give you an examples for diagnosing examples of applications or problems that we will diagnose, but instead I will focus on techniques and we will focus on collection and analysis of dumps. So in this webinar, I will show you those various tools that we have available and also the way how they work. And of course, we'll also look at the ways how we can analyze the memory dumps that we collected. So without further ado, let's start with some basic facts about memory dumps. Memory dumps are usually great. I mean, they are great for analyzing hangs and freezes or memory leaks. Those are the usual situations when we think of collecting memory dump. But those are not the only situations where memory dumps could help us. And we will, in a moment, we'll see the tools like ProcDump, for instance, that help us create memory dumps when, for example, we have problems with CPU spikes caused by our application. Of course, memory dumps are probably not the best way to diagnose those problems, but it's still possible. And in the past, when we didn't have .NET Trace and PerfView was being created and was not popular, we diagnosed also the CPU problems with memory dumps. So there are lots of information that we can read from memory dumps. And if you are interested, we have in this last webinar, I think we had an example of a freezed application. And of course, in the course, there is one module dedicated to freezes, and memory dumps are used a lot in various lessons of the course, because that's one of the basic ways how we can diagnose applications. And I want to underline, and I will also mention that a bit later, that choosing the right type of a memory dump is really important, because if we lack data in the memory dump, so if we, for example, take a mini dump instead of a heap dump, we might not find the objects in the heap or even information about the heap. We'll only see call stacks. And so that's one of the very important things when it comes to memory dumps. And I like to think of memory dump analysis as sort of digital forensics. So we have the data where there is a problem somewhere, and we need to find it. And when I when I work with memory dumps, I like to take notes during analysis, and not necessarily notes which are related to the main problem, because we usually, when we open the memory dump, we could have an hypothesis what could be the problem. But in more complicated scenarios, it's sometimes what we thought was the problem. It's not really the actual problem. So noting whatever unusual, taking notes of all the unusual things that we find in a memory dump could be very useful, because that could guide us in and to those different places in the memory dump that may be responsible for the root cause of our problem. And it is also when we have those notes, it is also good to write down the final solution. So if we store those notes, we can always grab through them and or search through them, and remember when we have another dump that is coming with a similar problem. So it's always worth to take notes of the steps that we took and our findings. And that moves us to the first part of the presentation, which is about collection. So I would group the ways how we can collect memory dump into two groups. So firstly, we can create a memory dump on demand. So that's the moment when we decide that, okay, this application is misbehaving. For example, it consumes too much memory, or it has this CPU spike or something else. I want to take a memory dump and have a look what is happening inside it. So analyze all the threads and check the GC heap and so on. Another group another way of creating a memory dump is by relying on an event. So this, for example, could be an exception, but it could be also memory consumption. So, for example, when the memory grows to some level, we want to create a memory dump automatically. We usually use the default configuration in the operating systems quite often is to create a memory dump when a crash in the application happens. And as I already mentioned, the types of memory dumps, we usually think of 3 types. There is also the 4th triage type, which is available in the create dump tool, for example. But generally, we think of those 3 types. So we have the full memory dump, which contains all the accessible memory in the process. Then we have the heap memory dump, which is the default, for example, when we when we instruct the runtime to collect a memory dump when the application crashes, and I will talk about it in a moment. And the heap memory dump is quite useful. I mean, it's usually enough. It's a bit smaller than the full memory dump. However, we had today I read in the course community that there is with .NET 3.1, I believe there is a problem with the heap memory dumps that they took much longer to collect than the full memory dump. So you might need to experiment with that. There is an also issue created I think in the .NET Monitor repository that describes it, but it's something interesting. I haven't observed that personally, but I also haven't used much. I haven't created many memory dumps with .NET 3.1, so maybe there is a problem there. And finally, we have this minimal memory dump, which contains only information about the stack traces, about threads, and exceptions. So this type of a memory dump is very useful when we need to diagnose exception that we caught. So we know what caused, we know why we are creating the memory dump. It's only for exception, and we just need to look at maybe call stack or some details in the exception object. Or we also could create this memory dump if we want a lightweight view into why the application freezed. This memory dump will allow us to look at call stacks and list the threads that are in the process. But generally, if only possible, try to create a full memory dump and get access to all the data in the process. I also want to mention the formats that we have for memory dumps, because they differ between platforms. And on Windows, it is an undocumented mini dump format. And on Linux, we use the ELF format. And that's maybe surprising for people who know that the ELF format is used for executables and libraries on Linux. And interestingly, there is a separate type called etcore where the same format is used to store the core dump information. So the sections in the file contain the memory of a process and not really the what usually you will think of. So the assembly code and the data sections. And finally, there is a different sort of memory dump, which is called a GC heap snapshot. It's not technically a memory dump because it's constructed by walking the GC heap, and the GC heap snapshot contains a GC heap objects graph. So we can look at the references between objects and look for the leaks in the memory in our application. So those, and of course, GC heap snapshots will not allow us to look at the properties, at the object's content, but they could be great if we need to, they are great if we need to diagnose a memory leak in the managed heap. So, and of course, we use them because they are much more smaller than full memory dumps that would contain similar information. So how we can create on-demand memory dumps? We could use system tools, and for example, on Linux we have Gcore, which is not necessarily a system tool, but we usually have it on the system. It's part of the GDP package. So if we install GDP, we'll have Gcore. And of course, Linux kernel creates the core dump on specific signals, and I will talk about it in just a moment. On Windows, we can create memory dumps by, for example, using the right context menu in Task Manager. If we select a process, right-click on it, we will have an option to create a memory dump. It is also possible to do in PowerShell. There are already I don't think that it's in box possible, but it's quite easy to use the Windows API for creating a memory dump. Then the one problem with those memory dumps that are created by the system tools is that they might lack the .NET runtime details. So the runtime .NET, the information about modules or the just-in-time compiled data, although it's usually in the private write region, so it will be in the dump, but we might lack information about the modules. So fortunately, .NET team created a create dump tool, which is distributed with the .NET runtime. It resides, as you can see in the slide, it resides in the same folder as libcore CLR libraries, so the .NET runtime libraries. And with this tool, we can create safe to use for .NET developers memory dumps when we can pick the type of a memory dump. So for example, normal with heap, that's the one, that's the probably most popular one and also the default one, or we can create a full memory dump. Then we also have a .NET dump and .NET Monitor. .NET Monitor is still in preview, and well, it's sort of a tool that we use when using containers usually, but I think it will become more and more popular with time. .NET Dump uses, well, it uses both those tools on Linux and I believe Mac, use event pipe to connect to the target process and then create a memory dump. Interestingly, even when we send, and we will observe that in a demo, even if we send a message through the event pipe, the actual tool that will create the memory dump is the create dump that I just mentioned. On Windows, both those tools use the system API directly, so they do not send any event pipe message, but instead use the WinAPI method to create the mini dump. And let's focus on Linux for just a moment, and let's switch to event-based memory dumps. So the memory dumps that we create when an event happens. And the first event that we probably think of is the crash of an application. And .NET, when it crashes, it raises the SIG abort, so the abort signal. And that's one of the signals. If we check the manual page for a signal, we'll see a table listing all the signals for which a core dump will be created. Of course, we need to enable it. We can do that with ulimit -c and then specify the maximum size of a core dump. We can also use syscontrol to configure various parameters of the core dump, such as name. And on systems which are running systemd, there is also a separate configuration in systemd dedicated to core dumps. So you just need to check on your system. But basically, when we have an .NET application which is crashing, it will raise the SIG abort, and that will cause a core dump, as we will see in just a moment. And then we have a prog dump for Linux, which is a really interesting tool. And if you have experience with prog dump on Windows, the Linux version has less options than the Windows one, but I think Microsoft is still working on it, and it's great that it's open source. We can check its code. And a prog dump for Linux in fact is a wrapper over two other tools. So for native applications or not .NET applications, it creates memory dump using gcore. So the tool that I mentioned that is a part of the GDP package. But for a .NET application, if it detects that's the .NET application, it will send an event pipe message to the .NET runtime, so to the .NET runtime running in the target process. And so it will create a memory dump in the same way as .NET dump will do. So that's really cool because proc dump for Linux is safe to use for .NET applications. And we have those various triggers that we can use. So for example, we can create a memory dump when CPU exceeds a specific value or when the committed memory exceeds a specified value. And today there was a tweet from the proc dump team that they also enabled support for creating memory dumps on signals. And that's really cool because apart from the system signals, we could use also our custom signals, which have those numbers with sig user and then 1 and so on. And so we can raise those signals and this way communicate with proc dump. So I'm not sure if we will use it, but it's one of the options now available for us. And on Windows, we have many more options. That's why you can see one here. And I will start with the AE debug registry key, which is really old. I think it existed even in the first versions of the Windows NT with the kernel, NT-kernel. And this automatic debugger allows us to hook an application, sort of a debugger or memory dumper, for example, when an application crashes in the system. And the configuration of this automatic debugger is under this registry key for 64-bit and this registry key for 32-bit applications. And interestingly, Visual Studio, when we install it, it fills this registry key with the debugger value, and it sets this value to the Visual Studio just-in-time debugger. I'm not sure in which version of Visual Studio they stopped showing this dialog, but maybe you remember in older versions when the application crashed, we always saw this one choose just-in-time debugger. I believe that I'm not sure how it handles the the problems in services. So in applications running in sessions without a desktop attached, because if there's a dialog like that in such a session, that would be problematic. That will stop this the service completely. So that might not be safe to use, but still we might re-enable this setting by adding or modifying the auto string value. And if we set it to 1, then this dialog will appear. And I will show you that in just a moment in a demo. Another way and I will say that it's a modern way of collecting memory dumps on Windows is by relying on Windows error reporting. And Windows error reporting has lots of various settings that we can configure, but one of them is the local dumps key. And I have debug recipes repository where I created a whole document about how you can configure Windows error reporting. And Microsoft documentation is also very good for to learn how we can use Windows error reporting. The reason why Windows error reporting could be very useful is that we could configure it also through the Active Directory. So we could have a share in our infrastructure when we collect memory dumps from various servers for further analysis. So that's one of the ways how we can do that. And it does not necessarily need to send them anywhere. It is possible to configure Windows error reporting to create the memory dump in a local share or local folder. And of course, you probably know those event logs that appear just after the .NET runtime log about an error in the application. We will see those Windows error reporting logs with some information about the collected crash. And the next tool is ProcDump, and as I said, the ProcDump version for Windows has many more options, especially when it comes to choosing the memory, the type of a memory dump, because we have, even in recent versions of ProcDump, we can create a memory dump with a part of the kernel memory that is related to our target process. And that is really cool because, for example, we can look into the kernel part of the handle that our process holds, or the kernel call stacks, and so on. So that could be very insightful. But of course, there are all other types of memory dumps also available, and we can even write our own callbacks for ProcDump. And we can create, apart from those CPU and memory committed counters, we can also use other performance counters when triggering a memory dump. And ProcDump is also aware of .NET processes, so it can, if we can switch the engine that ProcDump will use for collecting the memory dump. And I don't think I have it here in the slide, but generally there is an option. I think it's -G. So it will run a native debugger in a managed process if we have problems collecting the memory dump using the default engine, so that the one that works with the managed interoping debugger engine that is in ProcDump. And we can also install ProcDump as our AE debug, and that's a very useful setting, because with ProcDump installed as an EA debug, we can debug crashes of, for example, Windows services. So if something is running in session 0 and it crashes, then if we have the ProcDump hooked in this way, so in the AE debug key, ProcDump will create a dump in the folder that we specify here. And apart from those tools, the tools that I already mentioned for creating the event-based memory dumps, so the tools, I will call them native tools, we have a support in the .NET runtime for automatically creating a memory dump with when the .NET process crashes. And for that, we can use the environment variables, and their name changed in .NET 6. I mean, the old name will still work, but starting from .NET 6, the recommended prefix would be .NET and then underscore instead of the older com+ and underscore. And by simply using this environment variable and setting the enable mini dump to 1, we will start creating the type with heap memory dump, so the default for create dump. Internally, .NET runtime, when we have this setting set, when we have this environment variable set, .NET runtime will run the create dump tool, and with help of this tool, will create the memory dump. And we can specify by using other environment variables what type of memory dump we want to create, and also we can define the mini dump name and add some diagnostics logs if we are interested in them. Now, in the next slide, I want to focus on the GC heap snapshots that I already mentioned. They, as I said, they give us the GC heap objects graph, and they are significantly smaller than memory dumps and are great for analyzing the content of the GC heap. And to create them, we can use either Dotnetgcdump, which is a, I would say, modern tool, because it was it uses event pipes, so something introduced in the newer versions of .NET Core. But we still can use PerfView, and PerfView worked even for old .NET framework processes. So it was, and it had also a command line, so we could run PerfView heap snapshot and then process ID to create a GC heap snapshot. With Dotnetgcdump, we use the collect command, and then we provide the process ID. And now it's time for the collection demo. So I will minimize the browser and let's go to the console. So first we'll start with the core dump. I have a very simple crusher application, and it's just for the demo purposes. So when we click enter, it will throw an exception and the application will crash. And it's just to show you how the application behaves. So let's configure the ulimit C, and we'll set the size for the core dump to unlimited. And now let's run the crusher application. So it will crash, and we will see that there was an information about the abort signal, and then the information that the core was dumped. The core is here, so that's our core dump, and we can see that the size of it is 66 megabytes. And as an exercise in the analyze, after the analyze section, I will use other tools, but let's have a look at this core dump, so the one that was created by the kernel, what it reveals. And the first thing that we might notice, I already have the .NET source installed here, and you can see a message coming from it. And so I have the .NET source tools available. And if I run, for example, CLR threads to list the threads, we'll see that there is a problem with loading the DAG, so data access component. And unfortunately, that's one of the problems with the core dumps created by the kernel. So, and I guess that's one of the reasons why the create dump was created. We still can rely on the native commands, at least in LLDB. And I might need to add symbols. I have them downloaded. Target symbols add, and the path to my symbols is in the libcore. So let's see how the stack will look like if we enable the symbols for the libcore CLR, and we can see the method that raises the signal abort. We can see that it's in the proc abort method in libcore CLR, so in the .NET runtime library. So that's the place where when the final steps of the .NET process lifetime happens. So from this on, we have a seek abort, and after the seek abort, we have a core dump created. So with the symbols downloaded with the .NET symbol tool, we can access the libcore CLR stacks, and so we still can analyze some things. We can walk through the data that is available, but it's really hard. We need to look at the method descriptions and so on. So that's not really a great way of working with memory dumps. So I just wanted to show you in this demo that what error you might see when you create a core dump and try to analyze it. In Windbg, if you try to load this Linux memory dump into Windbg, which now supports Linux dumps, it won't be even able to show the libcore CLR stacks. So LLDB is in this part slightly better. Now let's have a look at how the process will behave if we set the environment variable that I mentioned in the slide. So let's copy the com+ debug enable minidump, and let's set it to 1. So let's use this variable. Let's set it to 1, and now I will run the crusher again. But before I do that, as you're in this webinar, you probably don't want to believe me, you want to see a proof that something works in a way I said it works. So we will also observe the processes that are starting in our session. And for that, I will use the exec snoop. So one of the tools that comes with the BPF trace toolkit, and the BPF is a modern way of collecting traces on Linux. It's a really cool technology, and we have a lot of interesting scripts available when you install a BPF trace application. I'm on WSL2 and the newer version of WSL. So if you have, I think it's Ubuntu 2004, and it comes with a Microsoft kernel that has the BPF enabled. So we no longer need to compile the kernel to get access to BPF on WSL2. The only thing that we need to do is to link the kernel headers under the lib folder. So I have the link somewhere here, and actually the description is in the WSL2 repository in the issues. You can find it. But the great part is that we can now run the BPF tools and listen, for example, for in this case exec syscall. So whenever a process calls an exec syscall, that usually happens after a fork in Linux environment, then we'll see that, and we should see a log here. So now we have this environment set. Let's run the crusher again, and this time we should see a message coming from the .NET runtime that it created a core dump in the temporary folder. And we can also see that the create dump was started. And so that confirms that .NET runtime internally, when we set this environment variable, used the create dump to create our memory dump. I will move this memory dump that we have here to the Windows environment, so I could use it a little bit later and open it in Windbg preview. So we'll look at the okay. So I will have the core dump to analyze in Windbg. Okay, so the next tool I wanted to show you, maybe the tool that you already know, is Dotnet Monitor. I have it installed here using the .NET tool command. It is available in preview, so you need to add this version before installing it. Of course, usually you will probably use Dotnet Monitor when you're running in a container, because I guess that's the main target for Dotnet Monitor, to run it as a sidecar container for your containerized application. But still, even if we run it in a system, we'll be able to look at the .NET processes that are running in the system. Of course, on a local system, it's quite easy to create a memory dump with a dotnet-dump tool, for example, but it's still a nice tool to work with. And one thing I haven't mentioned is that create dump requires a ptrace capability. So when you run the .NET Monitor in the sidecar container and you want to create a memory dump of a monitored application, you need to remember that this monitored container must have the ptrace capability. So that's something that when we forgot about it, the create dump will fail. So let's now access the URL. I need to use Edge because now the current version, and I think also the future versions of you can see that there is an error when we try to access the main page, but the rest of the APIs should work. Starting from, I'm not sure which version of Dotnet Monitor, but the authentication is enabled by default. And if I do not set anything in the settings, it will use Windows authentication. And that does not really work well. The handshake does not work well in Firefox, but it does work in Edge. I guess it's not surprising. So if we run the, if we use the processes endpoint, we can see the processes that are running, .NET processes that are running in the system. I will start the crusher on Windows, so we should see a new PID in our process list. So let's refresh it, and we can see that it appeared here. And I can copy the PID and then use the. But before I do that, I want to show you that with the help of Procmon, we'll monitor only processed event, that there is no additional process started when we create a dump using the dump, the monitor, the .NET Monitor. So here I'm creating a memory dump. As you can see, everything happens over HTTP, and that's really cool because the dump was created on the system, but I can download it through the HTTP. So I have the dump in the response, and that's really cool, as I said, especially for the remote access to containers. And also, .NET Monitor is pretty smart when it runs with one target application. We don't need to specify the speed. Instead, we simply call the dump command, and it will generate the memory dump for the one process that it monitors. So, moving back to procdump, which I have started, and if we look into the process tree, I will find the .NET Monitor. It created nothing, and the crusher application also did not create anything. So we do not see a create dump application started by the .NET runtime. So that maybe that not necessarily proves that .NET Monitor uses the system API. For that, we would need a debugger or tracer, but we can assume that by simply checking the trace in procdump. And that moves us to the next tool I want to show you. And also, let's have a little bit fun with event pipes. So let's, I have those few sessions. I will stop the .NET Monitor, close this PowerShell session. And in this window, we will do a little experiment and have a sneak peek at the event pipe communication. So we'll look at what actually the exec snoop will be useful. So we will have a sneak peek at what happens when we run the .NET dump and try to create a memory dump on Linux. So here I will start a simple application that I created called EP-snoop, so event pipe snoop. And if I start it here, I need to specify the PID of a process. So I will again start our crusher application, and let's leave it waiting. And here I will learn what its PID with .NET dump. So it's 194, and here I will start listening on its event pipe. I'm not really interacting with the Unix socket here. I simply create a Unix socket which will be first in the list that the .NET dump tool tries to find. And that's why it picks my Unix socket instead of the target socket from the crusher application. And this way I can proxy the traffic between the .NET dump and the crusher. So now let's create a .NET memory dump using .NET dump. So there should be some communication happening on the event pipe. We can see that we are proxying something. And the memory dump was created in the Windows TMP folder. So here we can see it, and we can also see that we recorded some traffic. And as I was still running exec snoop, we can see that the create dump tool was started. And this create dump was started also by the .NET runtime. So when the .NET runtime received a message, an event pipe message from the .NET dump tool, it created this memory dump. And so let's have a look at this, what we received here. And as an experiment, I already told you, and we saw that on Windows, .NET-dump does not use the event pipes. But does it mean that the .NET runtime, if it runs on Windows, does not handle this event? So what happens if we send the same event? So if we provoke the event, the memory dump by using the event pipes. Let's do that. So let's have a look at what was happening. The file that epsnoop created, actually it's here. The name is eventpipes.1. If I grab it here, I created a template for the hexadecimal editor that I use, and I can run it. That is this diagnostic IPC message, and it simply underlines or finds the parts in the binary traffic and decodes them. And if we look at the what's inside this, actually, I will move maybe the that would be a better place. Okay. No, always problem with docking. So first we have this header, .NET IPC version 1, pretty long one. Then we have a size of this whole message. And then we have a command that, okay, so sorry, misclicks. And then we have a category command, which is dump. So this first one here is dump. And then we have the sub command, which is create dump. So that's the message that goes to .NET runtime. Then we have reserved 2 bytes which are reserved, and then we have a payload for a message. So .NET Trace uses the same format. Of course, the commands are different here, and the payload is different because we have providers and so on. But generally, the idea is that we send the clients, such as .NET-dump or .NET Trace, sends a request, and then the server responds. And the server responds with, if everything is okay, the server responds with OK command, and we have zeros in the payload. And the IPC protocol is well documented. And here, for example, we have in the .NET Diagnostics repository, we have a description what goes into each of the commands. So we can, in case we need to, we can always have a look. So in our example, we see that there is the path to the memory dump, and then we have the type of a memory dump. Here it's the 4 here is for the full memory dump. And here we decide whether we want the diagnostics logs or not. So let's modify this message a little bit, and let's use a different path here. So instead of using the M and T, which will not work on Windows, let's try the CTMP. I would like to try maybe TMP test TMP, as that would be easier to configure. And if I switch back to our binary view, I need to remove the server response because I don't want to send it. And here I need to make some additional changes. So first of all, I need to change the size because now it's 4.0 instead of 6.0, because our whole message is 64 bytes, so 4.0 hexadecimal. And then our path here with the 0 character at the end is quite easy to set because that's 32, but those are Unicodes, so each character takes 2 bytes, and also the 0 character at the end takes 2 bytes. So instead of 2.20, we will have 10, so 16. Those are the 16 characters. So that's our payload that we can now send. And to send it, we will use PowerShell, because PowerShell can create the named pipes. I have a simple command created. I need to only set the PID. So I have the crusher still running. Let's learn what is its process ID. It's 3432. So in the PowerShell session, I will go to the CTMP. Okay, I think yeah, I said that. So it should be D here. That's my folder. So I need to go to the TMP, and from here I need to set the TPID, which will be 34. I already forget 3432, and now I can copy paste the command, the PowerShell command for creating sending the message. So we create a named pipe client stream, then our .NET, the named pipe created by this .NET process is .NET diagnostic, then process ID, and then we read the payload, which is, I see that there is a wrong path here. It should be DTMP event pipes .1 data, because that's the place where we saved our payload. And then we connect to the named pipe, write our payload, read whatever the server sends us back, and save this response. So let's try it and see. Before we do that, I will also again enable the proc dump. So we'll see if, first of all, if we have a new memory dump created here. Yeah, there is a test dump. So we can see that .NET Runtime on Windows handles this message properly. So if .NET Dump team decides to also use event pipes on Windows, they will work. We can see that they will work. And here we can see that .NET Runtime created the create dump process, and we can also find its parameters. So we have the PID, and then we see that it created a full memory dump, and the name of it will be DTMP test dump. So that was a little experiment that I wanted to show you, and also snoop a bit on event pipes. And the last way of collecting a memory dump would be, I forget that I promised that I will show you the AE debug key. So let's go there also. So that's the key in my system. I have Visual Studio installed here, and you can see that auto is set to 1. So when the application was crashing, nothing happened. But if I set the auto to, sorry, it was set to 0. Now, if I set it to 1 and then run the crusher again, so if I go to not DLL, that won't run, but crusher exe, and then throw an exception, we'll see this just-in-time debugger dialog, and we can break into the process and debug it. So that's, if someone missed this setting, it could be restored by using the auto setting here. I also mentioned the Windows error reporting dumps. So let's configure Windows error reporting to create a, I should not have close this path. Let's leave it open here. Let's create a memory dump using Windows error reporting. And in the there is a script created by the author of Inside Windows Debugging that we can use. I need to be in PowerShell, that we can use to configure var to, yeah, this one, to configure var to create memory dumps. But I need to be in the admin shell, because that configuration goes to global registry keys. So I will go to the TMP here, and then I will run the command again. And the two parameters that it accepts is the location of the folder when we will store the memory dump. So let's say it will be CTMP, and then the type of a memory dump. If we set it to 2, then they will be those will be full memory dumps. And if I go to the registry key for Windows error reporting, you will see that a new key was created by this script, local dumps, which set the dump type to 2 and then the dump folder to ctmp. And if I run the crusher again, so if I go to total commander, run the crusher, throw the exception, I probably don't have the procmon running. Yeah, so I won't show you the Windows error reporting process, but we should see a new memory dump created here. Oh, maybe I misconfigured something. Let's just have a look in the event viewer. And if I don't see it, I will just. So the Windows error reporting was running. So okay, that explains why I haven't seen it. Interesting. If it created the folder on C, you can check it. Oh, it created it. Okay, so we can see that it was smart enough to create the folder and create the memory dump. So I would not change it. You can see that it's running. We have a full memory dump of a process that was created by the Windows error reporting. So as I said, if we have an infrastructure, when we have Windows servers, we can configure them to, for example, dump those or save those memory dumps to some file share. It's good. I mean, it should be pretty fast. So the dump creation that does not take too much time. And to remove the setting, we simply need to delete this local dumps registry key, and the memory dumps will no longer be created. And the last collection tool I wanted to show you is the one for the Dotnetgcdump and Dotnet. Oh, actually, I will show you the Dotnetgcdump, not the PerfView, because PerfView we can easily click it, but Dotnetgcdump is slightly modern and I guess more popular with .NET Core. So we see that the PowerShell. It's not this PowerShell session. I will close this one, and the one I have here. Let's see how much memory it consumes. So that's our .NET process that runs the PowerShell core here, and in a separate tab, I will go to the DTMP folder, and let's use procdump, and let's set a limit on the memory to, let's say, 300 megabytes, and we will create a memory of this PowerShell application, or actually not create a memory dump, but we will create a GC dump. But I also want to show you how procdump can trigger a memory dump when the commit threshold is more than 300 megabytes. And to get this memory usage in this PowerShell process, I will simply list the files that I have here and load them into a hash map in the variable files. So we will have a files which will be a list of hash maps containing all the bytes in that we found in the DTMP folder. So let's create this hash map. Oh, okay. One thing I forgot. So I need to rerun this experiment. But at least you saw that procdump created our memory dump when we passed the threshold, so the 300 megabytes. But that's not what I wanted to show you. I wanted to collect the Dotnetgcdump for further analysis, so I need to rerun our command. I will create first Dotnetgcdump of the process before I read the core dumps. Maybe I should remove the memory dump created by proc dump because I will run out of memory for anything else. And now I will rerun the script that I had. So I will reload the hash map in PowerShell, and I will create the .NET-GCDump again. So we will have those two GC dumps to load into, for example, Visual Studio. Oh, this one takes longer. So as you can see, our process has more memory. So let's leave it. Oh, okay, it finished. So let's get back to the presentation. Now let's go quickly through the analysis, as I see we are running out of time. So first of all, we can use Visual Studio. And what's cool about Visual Studio is that it can open both memory dumps and GC heap snapshots. Then for memory dumps, we can pick one of the debugging engines, and that includes a managed, mixed, and native. So if we only are interested in the managed call stacks and metadata, we should pick the managed engine. But if we suspect a problem in the native part of the application or in the invokes that we make in the interoping, we should pick either mixed or native. And if you are lucky to have the enterprise edition of Visual Studio, you can also choose the memory debugging engine, which will allow you to analyze what's in the GC heap that we have in the memory dump. And there is also an option to run diagnostics analyzers. So it's sort of something that we use in Windbg, like bank analyze, to perform some automatic analysis of what we have in the dump. So it sometimes could be worth to run them. I guess that there will be more of them. Right now there are not that many, and with time they will probably detect some common errors. So maybe that will be the way how we will start our analysis. And a really great feature that I hope I will show in just a moment is that we can compare the GC heap snapshots that we collected. So by loading to the newer GC heap snapshot, we can compare it to some baseline GC heap snapshot that we collected earlier. And the great thing with Visual Studio is that we can now open Linux core dumps. We need to either add an extension, DMP, because the core dumps that are coming from Linux, as you could see, they do not have the extension. So we either need to rename them or remember to choose the open with option when we are opening a memory dump, and then pick managed Linux core dump. And that will make Visual Studio to open the core dump, and we can work with it as with Windows, the memory dump created on Windows. However, unfortunately, the native call stacks will not work because, the symbols for libc or other Linux libraries, they are not on Microsoft symbol servers, and symbol server protocol is not used on Linux. So unfortunately, we won't see those, but we can download symbols for libcore CLR and other .NET libraries, even the Linux ones. And of course, we have Windbg, LLDB, and dotnet-dump analyze, which all use the data access component, and that goes the analysis of the managed parts of the memory dumps in Windbg and LLDB are done through the source extension, and we load it using. We first need to install it. Although Windbg preview was able to download the source extension, and it almost always works now. However, when we have a Linux dump, we still need to use the manual.load source DLL, and I will do that in just a moment. And there are some useful diagnostics commands to start with. So first we have a print exception that we can use, then CLR threads, and in each of those, I'm not sure if dotnet-dump is not really a debugger, but in all those tools, any of these tools has a different way of selecting an active thread. So in Windbg, we use this tilde setting, and then the thread ID and switch command. Then in .NET-dump, we have set thread, and in LLDB, we have thread select. And we have commands to look at the CLR stack, so that's for the managed stack. Dump stack is for the managed and native stack. And pstacks, which is quite a new command, the contribution from Christoph, who is also, by the way, involved also in the diagnostics course. He had a live webinar. You definitely need to check it if you are subscribed to the course. He contributed this pstacks command, which is for parallel stacks, and it's now available in .NET-dump and LLDB, and it's really nice to have an overview of what is happening on different threads, managed threads, and with groupings of the stacks. So if there are common stack frames, this command will group them. And then we have other commands to look into the heap. So for example, we can print heap statistics for objects that we see in the heap, then some general heap information, also including the loader heap, and the GC root for looking for references, and other commands. And there are many more commands, and there's one lesson in the course dedicated to Windbg and LLDB, and Konrad prepared a cheat sheet based on this lesson, which is available in goodies.net.org. I should have it here so I can show you how it looks like. As you can see, the commands are nicely grouped into the call stacks, evaluation, memory operations, and so on. So it's and it groups the Windbg and LLDB commands. So when you are working with those debuggers, that might be handy if you forget some command. For analyzing the GC heap snapshots, we can use PerfView or Dotnetgcdump report. Although Dotnetgcdump report is quite basic, the output is very similar to dump heap stat command. So just maybe it can help to simply look what's in the heap. But the best tool, apart from, of course, Visual Studio that I just mentioned, for analyzing the GC heap snapshot is PerfView, and similarly to Visual Studio, we can use PerfView to compare the different GC heap snapshots. We need to open both snapshots, and then a new option will appear under the div. We can compare a given snapshot with a baseline. So the views that we are used to that show us the call stack now show the objects graph and object tree in the heap, and we can find the references between objects. And if any of those tools do not satisfy us, we always can write our own tool, and there is a great library available through NuGet, which is called Microsoft Diagnostics Runtime, or in other name is CLRMD. It is based like SOS on data access component, and actually .NET-dump uses it. And again, Christoph wrote an excellent article how you can extend .NET-dump by adding new commands, and he also describes this library. Also, Kevin wrote many articles about this library. So if you would like to write your own tool, just have a look at the medium.com and find their articles. And I also dedicated some posts to this library, and there is a lesson dedicated to it. So you might want to know it if you are interested in .NET diagnostics. I will just mention a few methods and the usual workflow. So we create a data target. With the data target, we can the actual engine reads the process memory, and we create. The data target, there could be different data targets, and one of them is memory dump. We can also attach to a leaf process. However, Microsoft Diagnostics Runtime does not contain a debugger engine, so it's simply a sort of a viewer analyzer, not a debugger. And data target allows us to iterate through the CLR runtime instances, so we can find all the CLR versions that are available in the process, and then create the CLR runtime instance, which is our introduction to all other options that I will show you in the slide. When we create the runtime, that's the moment when CLRMD looks for the DAC library, so for the data access component. And if necessary, it will download it from the Microsoft Symbol servers, of course, assuming we allow it to do so. Nowadays, it's not really a problem if we have a memory dump on a different, when we analyze the memory dump on a different machine than from which we collected it. It used to be a problem in the past. Now it's really easy. And when we have this CLR runtime instance, we can access all the .NET metadata, so pub domains, module types, then the details about a given type through the CLR type class. We can enumerate threads, and that's basically what the CLR threads command is doing in .NET-dump. And then we have enumerate stack routes, so it's also easy if we use this library to implement dump stack object command. Then we have access to the heap, and we can enumerate objects in the heap. We can enumerate references, and we can also start top-down analysis by starting from the roots of all the objects in the heap. And finally, we have a method to enumerate handles. And that was almost the last slide. The last will be thank you. So let's go to just brief demos how covering the analysis part. So maybe I will start with Windbg, and I will show you its support for the core dump that we created on Linux. So I will open the dump file in the TMP folder. We had this one, I think, was coming from Linux. So let's open it. And as I said, when we load the Linux core dump into Windbg, it won't allow. We need to manually load SOS. It won't be in the extensions. It won't be loaded automatically. So I have. And if you install .NET SOS, you will have it in .NET, and then run .NET SOS install, you will have it in the user profile .NET SOS folder, this SOS DLL. We can load it. And now if I run CLR, maybe not CLR stack, I'm interested in dump stack. I would like to show you also the native stack. So we should be able to see not only the managed call stack that caused the exception. Let's give it a moment. But we should also see, we can see that here we have this memory dump was created not when an exception happened, but when we were waiting for a keystroke. But we can see finished. So here we can see the managed part when we had this console read line, and then comes the native part. And notice that Windbg was able to download the libcore CLR, so that's the Linux, the .NET runtime on Linux. Windbg was able to download the symbols for this module. So that's really great. We can see what was the call stack, the native call stack, and which methods were called the last or are at the bottom. So which API, how we wait for the keystroke on Linux. And the last demo, I will use Visual Studio, and I will load into Visual Studio our debugger that we had. So as I said, we will start with the older one. That would be this one. And I will compare it with a baseline. So I will pick the previous one that we created. And we should see some growth in the memory. So here we can see that the hash table occupies almost 400 megabytes, and we can see that there are plus 12 instances and plus that much memory, which goes, and we can look at the references. So the hash table reference is called by the PS variable, which is just a type which calls a variable that we have defined in PowerShell. And so in our case, this will be this the files variable is of type PS variable. So there are even more PS variables, as you can see, probably created internally. But what's important is that we immediately see here what occupies the space. Of course, that was a very simple case, but that still can show the big benefit of using this compare feature in Visual Studio. And that I just passed the time, so that would be it. Thank you very much for attending the webinar. I hope you find some things interesting in it.
I believe so. It was pretty dense, like a lot of demos and other stuff that was pretty covering a lot of things that you could talk a lot more, right? Because
yeah, exactly.
Super fast overview of the tools, and then you have to analyze specific use cases to practice and so on. So a lot of topics to cover. We have some questions. So let me go through them and we will try to answer some of them. We had some discussions also when you are talking, but you can also, talk from your perspective. So we were surprised by Jose Silva. Was the very first question was about the memory management, not the diagnostics.
So question for Konrad.
I feel challenged here. So we have a question: what do we think which is better? Resource acquisition is initialization technique, which is kind of cornerstone of C++ like languages, memory management, or garbage collector. I would add reference counting here as a third kind of solution. And as always, there is no single fits it all solution. Every solution has their cons and pros. Personally, I believe I would not say any of them is really better, because there are some use cases like we have unmanaged languages like C++. The no overhead is at any cost the most important thing, and then simply we put some attention on the developer and we need to think about it during development, or we can put some effort on the GC and then it will think also to not instead of us simply, right? So
yeah,
I'm afraid of answering because it will take too much time. So let's just say it short. There is no single best solution.
Yeah. But generally, I would say that using garbage collector facilitates the way how we develop. Have a look at the Rust documentation for lifetimes. It just can blow your head.
Yes.
What you need to do if you use the RAII approach. And of course, I really like it. I mean, it's great if you can dispose everything when you're out of scope, but we know how life looks in big applications when we have various scopes which are interfering, and there are cross references. And
exactly.
Yeah.
And in the end, I mean, Rust is a perfect example when we are trying to help a developer, but in the end, she needs to understand memory management. Although probably it is not always necessary, in the end, it needs to think about borrowing, ownership, and then, unfortunate cyclic references. So
yeah, you need to be very strict when you're exactly cyclic references. That's crazy.
And you end up in the reference counting types of pointers and so on and so on. So no perfect solution. Sorry, Jose. The next question was, do dumps created via Process Explorer or proc-dump miss the .NET specific data?
No. Actually, on Windows the situation is quite safe, and that's I guess that's the reason why .NET Dump is also using the I think it's the mini dump right method in WinAPI. So proc-dump and Process Explorer, they both use. And when we talk about Process Explorer is creating full memory dumps. So we are safe here. With proc-dump, it of course depends which sort of memory dump we choose. But I would say, and as I mentioned, proc-dump has this ability to detect a .NET process. I haven't tested it thoroughly with .NET Core. No, on Windows 2, but I'm not sure if it works with .NET Core, to be honest. I need to check it, because it for sure it works for all .NET. It runs this interop engine, and thanks to this interop engine, we can set filters on .NET names of the exceptions. So, for example, we see this nice system exception name or whatever. And if we do not have this interop, then we will have those hexes which identify the CLR exception. So I'm still, even if it does not support .NET Core, if we create a full memory dump with, or even the heap memory dump with, so the private data memory dump with proc-dump, we should be good.
Yeah, that's good for us. The next question was how we can show the DB connections in the memory dump. I would say, I rephrase it, is there any source comment for that or any plugin?
I think I'm not sure about it, but I think the nettext extension, so the one created, I forgot the author's name, but you can find it in GitHub.
I will copy paste the link to it.
Yeah, maybe it has something. I remember that I used it to look, but I probably used the method table to look for those
comments. The hard way.
No, not really the hard way. You just need to learn the type. So let me look for the link. So maybe I will also paste it and come afterwards forward it.
Yeah. So let's assume that this nettext extension has something like that. I don't remember either, but probably there was something like that. I haven't used it personally. Okay, I'm scrolling through the questions. Okay, the next very nice question is, hi guys, can you give us some real-world scenarios from your past projects when it was necessary to take a look into the dump?
Oh,
many
of them, yeah. Before the GC dumps were created, that was my memory dumps. Before the GC dump and actually the PerfView heap snapshot was available. But even when they were available, and I needed to analyze what's in the memory, so when there was too much, when I was diagnosing memory leaks, I was always relying on memory dumps on that, and also freezes. That's all types of freezes that I saw in the applications. I was also diagnosing them with memory dumps, and of course, when there was a crash in Windows service, I tend to configure either the Windows error reporting or the proc-dump in the AE debug setting in registry. So all those sorts of issues, I'm usually diagnosing them with memory dumps. And Konrad probably can add some more with
very similar scenarios. So any kind of deadlocks or threading issues that are happening only on big scale on production, for example, or also some use cases for memory leaks when, again, the only way was to analyze it on production, and taking a memory dump was a pretty simple solution. Even sometimes this heap dump is not enough, because if I see a huge amount of strings and there is a problem with strings, I would like to see the content of those strings. So then I need to take a memory dump, for example, to look into them. So a lot of histories, unfortunately. Okay, let's look. The next question is, the question was about if you are not yeah.
I see. Yeah, generally try Visual Studio only when there's not enough information, or you don't have Enterprise Edition to analyze the content of the managed memory. Then switch to these low-level tools. They are, of course, more sophisticated, and they require the learning steep is much higher. So I generally recommend starting with Visual Studio, especially now when Visual Studio has all those sorts of analyzers, and it quite well supports memory dumps, even the Linux ones, as maybe you saw in some webinars. I haven't shown it, but
I must personally admit that I have this finger muscle memory that I start to, if I have something to analyze, I immediately open Windbg, for example. But now I need to think twice or even more, because I need to use to the fact that Visual Studio is really helping us in analyzing many things.
Especially the parallel threads view in Visual Studio. It's a killer feature. So to have this really nice overview of the threads in the memory dump and all the call stacks, oh, that's really great. It can't be compared with the ASCII view that we see in Windbg or LLDB.
Yeah, so it is aligned with our answers. Christopher was also answering in a similar manner. So if you can open it in the Visual Studio as your default action, and only then, if it is not support, maybe you need some specific SOS commands, then you will go to those low-level tools. But Visual Studio is a perfect choice, and we should start there. That's the note to myself also. Okay, there was a question about the Dotnet Monitor. This is an open source, and you can just install it as a global tool. So anymore? Okay, one nice question also. Instead of using CLI tools, maybe you can write some ad hoc interactive scripts using this.
Yeah, I was thinking that we could create a F# type provider for the memory dump. That would be cool.
So I believe Kevin was writing something like that.
Okay. I didn't know that.
Or I believe someone started to do that. At least I
that would be cool to have. I mean, the IntelliSense for the objects in the heap.
That's true. But the overall idea is very nice, because we have this API, the library, so you can write ad hoc scripts in F# interactive, Linkupad, whatever.
Yeah, I used Linkupad a lot. Now I sort of switched to Visual Studio Code and F# interactive because I spend more time on Linux right now. So I do that also quite often. I use the F# to. It's a much better language when for any sort of working with data.
Ivan has this concern about the API, but I believe it is pretty good. The API is good enough to write such ad hoc scripts, right? Maybe it's not command line, it is object oriented still, but it is just pretty simple set of commands to analyze.
Yeah, it's quite easy to find yourself in this API.
Okay, the next question is, we got a memory dump on Linux that was deep. And what was the rest of the dump? That's interesting. Half of a big dump was not the managed
heap. Not the managed heap. Whoa. That could be some. I mean, it depends what type of application it was. Was it like, for instance, media applications? They could have a lot of native memory because of the data, the sort of data they contain. I would not suspect with that amount. I would not suspect that it was a loader leak, because the loader leak would be also in the native memory, but I don't think that it would take 60 gigabytes.
Yeah. I mean, if there is any kind of JIT bump, maybe yes, but typically it shouldn't happen. It should not happen.
I would try tools like I'm not sure if I spelled it correctly, but there are those various tools for analyzing native memory usage on Linux, like Valgrind. I think that was one of the tools that can collect call stacks for the allocations, the native allocations. That's what I would try here.
Unfortunately, we don't have VM map counterpart on Linux, so we cannot look so nicely into the process.
We can always try strings. Look, if there are anything that that resembles anything. That's usually what I do when I start with this.
That's interesting question.
Yeah,
in general, I would also say, because there is always a question about measuring. So, what does it mean that segment summed up to something, which is how it was measured? Who said that? Because maybe we don't count free space. Maybe the fragmentation is not considered. So, yeah. That would for sure require. At that moment, we don't have any simple and.
One more thing just came to my mind. Instead of using Valgrind, which might not be available, you could try also BPF and set up hooks on the allocation methods, on the heap allocation and on the, or you can set up the hook on the alloca, or what was the name of the syscall in Linux for allocating memory. So that will be one place that you can hook on and then collect the statistics. I think that there is already a script for that in the BPF toolkit. So, but still, it's not, of course, for analyzing, it's for tracing. So it's not really an answer to the question, but rather.
That's in general interesting question, Peppa. So you can reach us on Twitter, for example. As we don't have enough things to do, we can start analyzing yet another one.
Well, but 130 gigabytes.
Yeah, send me it over email. We will see. Yeah. So that's all. I believe almost questions. All questions has been answered. Christoph is saying you gave the link to Kevin work. I haven't seen this. So
I know. I think that Christoph said that send this link to the dump to Kevin.
Okay, maybe. So slowly ending because the time is ticking. So the very last minute for any more questions. If you have any, you feel invited to look at this page of the .NET Diagnostic Expert course, because what we have covered today is just a top of an iceberg, as it is said, as far as I remember. So we have covered some tools and showed you, like GC heap dump was presented in 1 minute. And then in the course, obviously, we have a whole lessons dedicated to using various tools and diagnostic scenarios and homeworks to make. So that's, I believe, super.
Not very easy homeworks. Some of them are challenging.
Yes. I mean, even reading the homework script is tiresome. You feel that you will have a lot of things to learn, but that's the goal, right?
Exactly.
So you have prepared those scenarios to analyze, because that's the best way how you can learn. Even if something is obvious when watching, then you start to diagnose something and you have completely no idea from where to start. So then in your script, there is a description, start there, use this tool, look at that or this, to try to move further your analysis. So I really like your homeworks, like in this course. So I'm just prolonging this ending a little, hoping there will be at least one more question, but it seems there is no. So thank you, Sebastian, very much for your insight about memory dumps. And
thank you for having me. Thank you for participating.
Yes, thank you for being with us, and look at our channel, subscribe, as YouTubers are saying, give us a like, and so on to make us more visible. Oh, we have one more question at the very last second. So is there also something about analyzing native code? Sebastian, the question to you.
Oh, okay. So, not really, because we do not have a GC heap, so we do not have. Of course, when we talk about the native, for the native code, that's usually in C++ or other language. We do not have the heap that we can analyze this sort of metadata. So instead, what we do with the native memory is usually first of all we need to have symbols, and if we have symbols, then we have those sorts of roots, because, for instance, the static variables in the global variables or static variables, they will be available through symbols. So those could be our starting points, and in LLDB, in Windbg, we can always list them. Of course, find the symbols, then look at what the classes contain. So I would say that the most important thing is to have valid symbol files, and then try to do what the GC, the dump stack objects command is doing in Windows. So in .NET. So for example, look at the call stacks, switch through the frames, look at the objects that are referenced from the stacks, then look at the static variables, and you will build the sort of a view of what's in the native heap. Of course, that won't cover all, but that could be enough.
Exactly. And I'm not sure if the question is about memory dumps in general, or maybe about the course. It's the whole course.
Okay.
Maybe, I'm not sure. So in general, you are covering, like, the course is about .NET, so obviously the native part is not important, but still there is this big native part called runtime. So you are covering mostly symbols, right? So how you can decode things when you analyze.
Yes.
So yeah.
And I would say that the course also covers the mixed content. Of course, it does not focus on native, so I don't show Valgrind or other tools on Linux for analyzing native memory. I have a brief introduction to VMMap. One exercise in the homework is actually a leak in the native memory, but I would not say that the course is. I would say that the main subject is native memory. It's rather somewhere in the background. So we use it, but it's not the main topic.
Yeah. So there is one homework for you about analyzing native memory leak. But I'm doing this also and talking about .NET processes, because sometimes .NET uses unmanaged resources, some libraries. And as we
many times, anytime we interact with the system. So whenever we create a file or whatever, mutex or things like that, we always have this the native parts involved.
Those parts may also grow.
Yeah, exactly.
And as Peppa has asked us, maybe even to dozens of gigabytes. We will see on Twitter, maybe he will reach us. Okay, so I believe now it's just a very good time to end, because we are almost 2 hours, like 1.5. So once again, thank you, Sebastian. Thank you all from all around the world, from Mexico to Poland and even further. So I hope you have a nice evening, morning, or whatever time it is now in your country, and see you someday somewhere look at the .NETOS channel, because we really like to provide premium content about .NET in general in various aspects. So be with us and see you soon somewhere in the internet. Bye.
Thank you. Bye.